Applying Pascal's method. So we're going to take the Pascal's triangle and apply it to a couple of different array style problems. In the first one, determine how many different paths will spell Pascal if you start at the top and proceed to the next row by moving diagonally left or right. So in this case, the P at the top becomes 1, and there's only one way to get to the A on either side. And just like Pascal's triangle, all the outside letters are only accessible in one way. The inside differs a little bit. Again, just like Pascal's triangle, there's two ways to get to that middle S. And then we start the process, just like Pascal's triangle, of adding the two above. Here, we can get there 4 ways. In the middle, 6. On the end, 4. And these numbers are identical to Pascal's triangle. So you'll notice that it is an or situation, this way or that way. So at the end, we add up the two values. And there are 20 ways to spell Pascal. My second example is a checkerboard. And in this scenario, the checker can only travel diagonally upward. It cannot move through the square containing an X, so determine the number of paths from the checker's position to the top of the board. So again, we're going to go backwards, this time upside down. There's one way to start and one way to get to the next diagonal, and that holds true all the way up on both sides. Just like Pascal's triangle, there are 2 ways to get there, 3 ways, and there are 4 ways to get to the next row. And we cannot pass through this square. So to work around that, we keep our values of 4 coming this way. And now we have 4 in the corner. Actually, let me back up there. I missed one. To get to this square, it's actually 5. You can get there 4 ways and 1 way. The corner, however, is still 5. This becomes 9, becomes 8, and becomes 8. So again, adding those numbers up, 5 plus 9 plus 8 plus 8. So that's 16 plus 14, which will be 30 ways. Thanks for listening.